Hi, I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, November 1st. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype. Looking at significant wave heights for the North Pacific Ocean, we see remnants of a gale producing 20-foot seas aimed north over the Gulf of Alaska and aimed only at Alaska, offering nothing. But another gale has pushed off of the North Kuril Islands, is producing 23-foot seas targeting Hawaii reasonably well, but a good long ways away from the U.S. West Coast. So there is something in the water that's starting to look like fall. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they do form, help direct their track. We're looking for a trough that is a dip in the jet going south, and there's kind of one there. There's one there. What that helps do is set up a counterclockwise flow aloft, and if it's strong enough, that also manifests itself down at the surface, and if it's strong enough, it generates winds. If those winds are strong enough, they generate seas. If the seas are high enough, they start radiating away from the fetch area and turning into swell, and swell, when it hits your beach, turns into surf. All right, so we have sort of a trough here off the Kuril Islands, but notice there's winds also pushing up into the Bering Sea, so that's kind of a cut-off trough. And then we have another trough here in the, I'll say the western Gulf of Alaska, but it's super pinched and not offering a lot to support gale formation, so kind of a mixed bag. Generally, the jet, though, is pushing off Japan, running over the dateline on about the 42 north latitude line. And there's been this massive ridge that is the opposite of a trough, pushing north. That supports high pressure aloft, which has been locked over California, which is making for beautiful weather and a nice blue, blue skies, sunny days, but not doing a whole lot for winds, weather, snow, or surf production. All right, so moving out into the future, we get into Monday. This trough over the dateline is supposed to get a little bit more organized, and notice the edge, the leading edge of the trough here in the Gulf of Alaska eases closer to California, but not quite making it. Now notice, as we get into Tuesday, a legitimate trough is almost forecast developed. It looked better a day or two ago, but still possibly developing as we get into Wednesday in the Gulf of Alaska. But then again, look at that, very pinched again. And then now here's a big trough over the Kamchatka, that area, but not over open water, not doing anything. Instead, a massive ridge taking over the dateline region. So big amplitude jet stream here. The jet pushing way up into the Bering Sea, then falling way south, almost down to Hawaii, and then quickly pinching off and then racing back up to the northeast. Again, not great for gale formation. Maybe a little something on Thursday there in the Gulf. Also notice the jet pushing from Vancouver Island down into Washington, into the Pacific Northwest, and bulging south from there. Weather for sure in this area, the models have been suggesting it, snow, rain, but the question is, will it make it south of right here, the California-Oregon line? And that is, it suggests here that the jet is supposed to race down the coast, but inland. The question is, how much moisture will that bring with it? This is the classic La Nina kind of setup. High pressure, in control out here, drives the jet way to the north, inland, and then the jet pushes down the U.S. West Coast. Instead of picking up copious moisture off the Pacific, it's more of a dry front, lots of cold air with it. When it does bring snow, it tends to be very light, good quality snow, but by the time whatever moisture you're going to get, it's mainly going to be up here in British Columbia, Washington, maybe into Oregon. By the time it gets into California, all the moisture is pretty much wrung out, and it's just cold, windy, and dry for the most part. All right, so we're into Saturday now, looking for, again, just this trough holding over the U.S., but nothing over the Pacific, pretty much ridging, a split jet stream, in fact, at the dateline. All it does is help set up high pressure between the two branches of the jet. So nothing there, and we're a week out, and still no real indications of anything. The models hold a little bit of hope. All right, let's go take a look down at the surface. Here we are, surface level pressure, surface level winds, low pressure in the Gulf of Alaska generating 35 knot, mainly south winds targeting Alaska, nothing at the greater U.S. West Coast. High pressure in control there, you can see it, not strong, 10-20 millibars, pretty weak. And a low pressure system pushing off of Kamchatka, almost to the date line now, producing 30-knot winds, and we know there's seas there, and they're targeting Hawaii and the U.S. West Coast. That continues into Monday, but the low pretty much fades out. You can see it easing its way into the Gulf, trying to generate some 30-knot fetch over a very thin, weak kind of area, not doing a whole lot. Again, 45-knot winds over in the far west Pacific as we get into Wednesday morning, but all out of the south, aim north, doing nothing for our area. Then finally on Wednesday evening, we know there's a trough here. Fetch starts falling out of the North Gulf of Alaska, 40-knot winds aimed at the U.S. West Coast, potentially getting some traction. There's also this fetch thing here north. We'll call it a cutoff trough or something. There's high pressure here, low pressure underneath, creates a gradient, generating 30-35 knot winds north of Hawaii. Most of the fetch aimed well west of Hawaii, but maybe some sideband energy pushing into the Hawaiian Islands. Then you see this 1044 millibar high. That is a bulletproof, strong high pressure system set up in the Gulf of Alaska on almost Friday morning, Thursday night. Low pressure pushing down the U.S. West Coast. There's that steep trough right in there. The gradient, the difference in pressure between the low here and the high here, tightens the isobars. They get closer together. That's what generates wind. Wind starts building, and you see it by Friday morning. 30-knot to 35-knot north winds just raking down the whole U.S. West Coast. That will do a lot for upwelling and dropping what was pretty nice water temperatures. That'll wipe that out right quick there on Friday. The 1040 millibar high moving into setting up shop over the Gulf of Alaska, where typically you'd want to see strong low pressure. We're seeing the exact opposite. Again, a La Nina sort of symptom. Saturday, again, more north winds, more local north wind swell there. We'll talk about that later. And we're just looking for any sign of legitimate swell-producing weather systems. We're a week out. We don't see it. So that's kind of that. Let's go take a look at the wave models. Now we're going back to Wednesday evening, the 28th of October, so a couple of days ago. A gale developed just west of the dateline. Not a huge system, but it had a little bit of punch. As we got into midday Thursday, 41-foot seas were suspected in the center of the system, building to 42 feet on Thursday night, pushing over the dateline, sort of arching to the north. A little bit of sideband energy radiating towards Hawaii, but better targeting the U.S. West Coast. That gale pushed into, we'll say the northwestern Gulf on Friday evening and installed there with, what was that? It was up to 30-foot seas on Friday and then faded. Swell is in the water, pushing towards Hawaii and the U.S. West Coast. I think it's supposed to arrive in Northern California tomorrow. Probably be bigger on Tuesday. Nothing huge, just rideable. That's it. Another system developed off Kamchatka at the same time. We'll go back, actually, here we go. It started on Saturday. By Sunday, we had, 26-foot seas, and then it, started fading. Now let's go off to the forecast. Here we are. Falling over the dateline, expected Monday morning, but pretty much dissipating, barely 20-foot seas at that time, then fading from there. Certainly some swell for Hawaii is expected, nothing huge, but, a couple feet overhead, and maybe some energy into California. We're into Wednesday now. Thursday, we know there is a gale forecast falling through the Gulf. Nothing, 24-foot seas over a small area, aimed well at California. The issue is when the swell arrives is also when that trough starts digging out and the wind machine ramps up. Also knows seas here. Let's go back. Seas north of Hawaii. Yeah, that's on Thursday night and Friday. Anyway, the wind machine starts on Friday in California, so whatever swell is generated also is going to be blown out instantly with locally 20-foot seas from winds, strong winds along the coast here. So maybe some protected nooks and crannies will get surf, but mainly wind swell, unfortunately. The swell will just be ripped apart. And we get into Sunday, and we're looking for anything here, and no clearly organized weather-producing systems after that into next weekend. So wind swell will be the name of the game next weekend. That said, last Sunday, a week ago, the 25th of October, a gale developed in the deep southeast Pacific. There you go, 34-foot seas were generated. Southern California cutoffs about 118, 117 right in there. And this system, produced some seas. Sideband energy is radiating north, expected to arrive in Southern California. I believe it's tomorrow. Nothing huge, but, the good, well-exposed south-facing spots that handle a real south-angled swell in Southern California could see rideable surf from it. Then there was another system that developed midweek last week. Right here you can see it. 40-foot seas building to 42-foot over a small area, continuing, and then faded. I'm going to go back and take a look here real quick, but because it did kind of push off to the northeast before it started crashing south. There is a better odds for swell from this one for North and Central California from a decent angle and a little bit of size. That should be starting, mid to later part of this coming week. So that is probably more to look forward to than the northern hemi swell. But then after that, so here we are at current time, 18Z Sunday. We'll go off and look at the forecast. Here we are. Now there is a little gale forecast in the deep southeast Pacific, but it's east of even the Southern California swell window. Nothing for our forecast area. And after that, the southern hemi will just blast through here. Really, nothing of interest is forecast. You see, there is this little system here, right here, Saturday, and this just showed up on the charts. What is that? 35-foot seas aimed kind of northeast. I don't believe anything that's, 4 or 5. Oops, it even went up to 37-foot seas there. Don't believe anything that's 5 or 6 days out on the model, almost 7 days. But if this were to materialize, another pulse of very south-angled swell could result for California. But given the time of year that we're in November, it's pretty much the expectation is that the southern hemi is going to go to sleep here pretty soon. So a quick wind swell inspection for Hawaii and the U.S. West Coast. We kind of already know what's going to happen. Nothing until that trough starts building along the coast, and then the wind machine. We're actually looking at Hawaii here. See, no. Here comes the low, and the wind machine follows directly. Right about, and notice I didn't see this. The 1040 millibar high, it actually kind of like sweeps on here, starts producing east wind swell for Hawaii on Thursday, and then it's Friday, it's Thursday afternoon into Friday. That's when the wind machine starts in earnest for California. 30-knot north winds, even 35-knot winds from, we'll say, south of Monterey Bay to Point Conception on Friday morning, and a good solid fetch of 15 to 20 knot east fetch for the Hawaiian Islands, and this low over here, maybe that's generating some wind swell. But most of the energy looks to be going towards the east shores of Hawaii. So we get into Saturday, 30-knot north winds along the coast of California. Sure, wind swell, but just a blown-out mess. And even as we get into Sunday, more of the same, more east wind swell for Hawaii, and there we are a week out. So plenty of wind swell looks possible. What about the odds for weather rain for California? Well, we know where the target is. It's somewhere around the Thursday-Friday range. We're in Thursday. We see snow up north into British Columbia, coming into Oregon, pushing into Northern California Thursday night down to about Point Arena, and snow even in higher elevations as we get into Friday morning, but no, and even precip down into Tahoe, and maybe as far as Kirkwood there, a little maybe smidgen of snow at higher elevations, but nothing into, we'll call it Central California proper at all. Rain off the coast, but nothing on shore. So we get into Saturday. Another little pulse maybe on Sunday, but again, the same scenario. Dusting at Tahoe. Sure, there probably could be some showers into the Bay Area down into Monterey Bay, but probably that might even be optimistic. Total snow accumulation for Squaw Valley in that area. What's that? Maybe an inch or two at best. Of probably more interest is the temperature profile. So this is the bottom of Squaw, top of Squaw, and the white is freezing temperatures. You see, so the freezing line up about 12,000 feet into about the 6th of November, I guess that is Thursday or so. And then temperatures drop significantly with the snow level down, or the freezing level down to 3,000 feet, and then rebounding. So that's good for snow making. In fact, very good for snow making, but not a lot of natural precipitation. And winds peaking up as the front pushes through in the maybe 70 knot range. Over the ridge tops at that point in time. Likewise, we're in the Bay Area, Mount Diablo, just looking generally at temperature levels. Freezing level down to about 5,000 feet, maybe even down to 4,000 feet, just barely above the top of Mount Diablo here on Saturday a.m. and again on Sunday a.m. a week from now, if you believe the model. So definitely a change in the weather pattern for sure. Then on I-5 on the Grapevine in Southern California, same sort of thing, a drop in temperatures by, looks like Sunday afternoon a week from now, and then again into Monday afternoon, but not quite as bold, not as broad an area, the front sort of getting, chopped up or weakening as it pushes further south. All right, so let's go take a look long term. What's going on with the MJO and, of course, La Nina? As usual, first we're going to look for the presence of the active phase of the MJO. The MJO, the Matt and Julian Oscillation, is this periodic weather oscillation. It travels on the equator from west to east around the planet. There's an active phase and an inactive phase to it. The active phase, when it's over the Pacific, takes about 4 or 5, maybe 6 weeks to traverse the Pacific from west to east. When it's there, if it's strong enough, it is in fact a low pressure system. It transfers energy to the jet stream, and if it's strong enough and you get multiples of them back to back, they can help kick off El Nino. But what you typically want to see in the active phase of the MJO is the first symptom is winds die or start reversing direction, opposite of trade. So what we're looking at here is data from the TAO buoy array, series of buoys strung across the equator. This is the East Pacific here. So California is about 122 west to 118 west. So this is on the equator. So this goes almost to Ecuador on this side, and over here that's New Guinea. The date line's right there, so the far west Pacific. And again, there's sensors on the buoys, and the arrows indicate wind direction and wind speed. The longer the arrow, the stronger the wind. So strong east winds over the East Pacific, continuing over the Central Pacific, then weakening a little bit over what we call the Kelvin wave generation area, the far West Pacific from 170 west the whole way over as far as you can go to about 135 east, 5 degrees north and south of the equator. If you see winds dying in this area or even reversing direction, that's a sign of the active phase of the MJO, and that's good because that can transmit energy up into the jet stream, help feed the storm track, and then help give us surf. All right, but it is anomalies, the differences from normal for this time of year. So we have strong easterly anomalies, but you look, there's almost no arrows present here, no directional indication. So that is pretty typical for this time of year. Over the Central Pacific, though, you see the arrows coming out of the east, meaning trades are a little bit enhanced in this area. That's not an indication of the active phase of the MJO. If anything, it's a more indication of the inactive phase of the MJO. Then you get over the Kelvin wave generation area and you see the winds start dying. So, yeah, maybe there is some weak active MJO thing going on here, but nothing too obviously strong. No reversal of trades. So let's look at the forecast. All right, this is a funky chart. This is the whole planet on one chart, but the date line runs right up the middle here. And the Kelvin wave generation area starts just east of the date line, so right there. California is about 120 west, so right there. This is just on the equator, 5 degrees north and south of the equator. Right, Kelvin wave generation area, the area that transmits energy into the jet stream if the active phase is over. It goes from here, so you go right up the chart from there to about there. The blues are easterly anomalies, indicative of the inactive phase of the MJO, and you see we've had a lot of that all month of October. A little bit of what appears to be the active phase going on right now, very weak westerly anomalies, but starting tomorrow, even starting today, easterly anomalies are forecast to take over, inactive phase of the MJO, just locking things down. You could almost say the active phase has been over here in the Indian Ocean. It's making its pass across the Pacific today, and then it's going to set up south of California, but that doesn't do anything. It's the Kelvin wave generation area, that area again we talked about in the far West Pacific. That's where the active phase has to be. It has to be generating westerly anomalies in this area to transmit energy into the jet to feed the storm track, and we're just not seeing that happen, and it's not forecast to happen for the next week. Let's look out a little further. Another component of the active phase of the MJO is cloudiness. The more clouding, remember the active phase of the MJO is like a low pressure system. It stomps on the trade winds, also creates clouds. So these charts are forecasts for cloudiness. They call it outgoing long wave radiation, OLR. But basically what we're looking for is the blues are more clouds than normal. We're not really seeing that. It looks like there was maybe a weak active phase of the MJO. Oh, this is South America, Central America, Mexico. EQ, that is the equator. 180, that's the date line. There's Hawaii right there. And then you see there's New Guinea, Australia. So the Kelvin wave generation area right around in here. And we're seeing no signs really of the active phase of the MJO. And if anything, the yellow is the inactive phase of the MJO. It starts building in we'll say about 10 days out from now. But then, according to the statistic model, that's what this is, it just fades, so kind of a neutral pattern. But the dynamic model is not a whole lot different, but maybe a little bit more biased from a neutral pattern moving to the inactive phase of the MJO. All right, let's dig in a little deeper. So these are the same two models, but now we're going to get a different perspective. These are called phase diagram charts. So that circle in the center there, assume that is you're looking down on the North Pole and our planet spins underneath that, right? Okay. And the MJO travels around the equator from the West Pacific to the East Pacific, over under the United States, across the Atlantic, over North Africa, back to the Indian Ocean, to the maritime continent, round and round it goes. Where the heavy dot here, that's where it is. That's where the active phase of the MJO is. So it's in the West Pacific. That's exactly what we want. But the closer the dot is to this circle, the weaker it is. We want to see that dot like out here or even out here. So a very weak active phase, and this is the forecast track here. This is where it's been. You can literally October 14th, 15th, 16th. You get the idea. Okay, the 31st, it's right here. Then here's the next 2-week forecast. This, per the statistic model, has the active phase of the MJO remaining extremely weak, moving to the Indian Ocean. The Cfs model, dynamic model, says basically the same thing. Very weak active phase, making it to the Indian Ocean. None of this does any good for us because where we want to see the active phase is somewhere between about here over to about here. So up in these two quadrants here, and we want to see it strong. It's in the right quadrant. It's just too weak in both cases, and forecast moving out of those quadrants, so that doesn't do us any good at all. So let's go out a little bit further. 40 days. All right, so this is yet another view of the MJO. MJO is, of course, low pressure. It creates clouds. It also creates precipitation. This is upper level potential for precipitation. The greens are favorable for precipitation, the yellows not so favorable. So you could loosely interpret it as the greens are the active phase and the yellows are the inactive phase, and what we want is the active phase. All right, so, and this is in 5-day increments. There's South America, the equator, 0 right there. Okay. New Guinea right there, so the date line's probably somewhere about there. Kelvin wave generation area right in here. So today, pretty much a neutral pattern. Looking out, neutral, neutral. Here comes the inactive phase, it looks like, but even that's pretty weak. This is on November 15th, and it meanders across the Pacific through the end of the model run. A weak active phase tries to set up maybe early December into mid-December, but it too is just very weak and ineffective, so there's no clear indication here of anything that is going to support storm formation or energy transfer into the jet. Let's look a little bit deeper. All right, so here's another one of these charts. This is the whole world on one planet. We're looking at east and west wind anomalies. The blues are easterly anomalies. The reds are west anomalies. Here's where we are today. Kelvin wave generation area. The east side starts right there, about 170 west, goes over here to about 135 east. The solid contours like that, that's the active phase of the MJO. So you can see it back in early or mid-October over the Indian Ocean, making its way across the Pacific. A little bit of westerly anomalies the past, 5 days or so. And you can see it shows it as a separate event here, but this is all really connected, one solid contour. You can see that as the active phase over the next weeks moves south of California, 120 west, it wakes up, produces all kinds of westerly anomalies. Unfortunately, that does nothing for us south of California. It's got to be in the Kelvin wave generation area, and instead what we see is the blues setting up and just, if anything, getting stronger as we get into Thanksgiving. Just easterly anomalies in control. Here is the inactive phase of the MJO. It's not, and there's a little piece of it there. My guess is it's actually going to move across the Kelvin wave generation area in around Thanksgiving, something like that. But there is a base La Nina state, and that's what this purple is. In fact, here we go. Low pass filter, the purple line. The dotted line means high pressure bias. That's synonymous with La Nina. And so what happens is that is in control. It has been in control. La Nina base state controlling the dateline region and, for that matter, the bulk of the Pacific. So even when the active phase passes over it, it pretty much gets canceled out and just, nope, you don't exist until the active phase moves beyond where the core of the La Nina focus is. And then it wakes up and goes, hey, yeah, I'm strong. I can produce westerly anomalies. Unfortunately, it does nothing for us. This is the curse of La Nina, if you will. And then when the inactive phase of the MJO syncs up with the high pressure bias, it like supercharges it, and then you just get super strong easterly anomalies. And again, that does nothing for transferring energy into the jet or for helping the storm track. And then finally, the 3-month CFS model, right? This goes backwards. This is past performance down here. This is the forecast looking up here. Kelvin wave generation area starts about 135 east, so right there going the whole way up the chart, to about 170 west right there the whole way up the chart. So right here in the middle is what we're looking at. And just looking forward, I see easterly anomalies, a little hint of westerly anomalies in the December timeframe. So maybe that's the active phase of the MJO. Strong easterly anomalies and more easterly anomalies. Not good. Let's overlay the MJO. We'll test our skills here. All right, so here was our current active phase of the MJO. And yes, it's passing over the Kelvin wave generation area. It's making westerly anomalies in the Indian Ocean, easterly anomalies over the dateline, and westerly anomalies south of California. That's the forecast, but nothing, and we know why, because of the high pressure bias that's there. Anyway, inactive phase of the MJO is to set up from about, let's say a day or two from now, and go the whole way into, we'll say, the first week of December. Easterly anomalies in control, no real support for storm development. That doesn't mean there won't be storms, but the odds are not favorable for big, powerful storms. Not anything like what happened in the Atlantic last week with Hurricane Epsilon that then got supercharged by the jet and just went nuts in the North Atlantic. That's where all the energy is. Anyway, then we get into, we'll say, late Thanksgiving, early December, maybe a week weak active phase of the MJO's forecast with a little bit of westerly anomalies. So that would be sort of a sweet spot for some storm development. Maybe a weak inactive phase following that right after Christmas. You know, I mean, this all just, you don't get active and inactive phase this close to each other. And so it's just sort of a oscillating pattern of nothingness for the most part, with easterly anomalies in control just east of the dateline. So no strong pattern forecast, and if there were a bias, I'd say it's toward easterly anomalies. In fact, let's overlay the low pass filter. Here you go. This tells the story. The dotted contour again, there's the dateline. High pressure bias over the dateline. Forecast to hold for the foreseeable future into the end of January, and if anything, building with a third contour line setting up. The low pressure bias right here is this is the Indian Ocean. This for 2 years was sitting smack dab over the dateline, but last summer they flipped. The high pressure bias built in, the low pressure bias started building in the Indian Ocean, and this is how you get La Nina. High pressure takes over the Pacific. The storm focus becomes Indian Ocean or even North Atlantic, and that's where all the energy is, and the Pacific sits high and dry. All right, so then we move away from the MJO discussion. We start talking the La Nina discussion and what other signs are there in the ocean of La Nina and how well is it dug in and how long is it going to last and all that kind of stuff. So again, TAO buoy array data, a series of buoys strung across the equator. This is the West Pacific here. This is the East Pacific here. That's on the equator of the Pacific. And the X's here, those are sensors on the anchor lines of the TA array buoys. They get temperature data at various depths in the ocean, relay it up to a central processing center in Maryland, and then you apply a model and you can get a profile of the ocean temperatures. All right. So you have, and this is centigrade, 29 degree centigrade. That's warm water in the far West Pacific. 28 degree isotherm is at about 176 west. I think that's where it was last week. We're very close. 24 degree isotherm, 136. That's within a degree or two of where it was. And considerably less warm water in the far East Pacific. I mean, this clearly points that the trades are blowing from the here to this direction from west to east, taking warm water that was here 2 years ago, pushing it over into the far West Pacific. And if you didn't know, there was a super typhoon that impacted the Philippines maybe 2 days ago. Max sustained winds were 190 knots. That's quite strong indeed. All that fueled by all this warm water in the far West Pacific, all driven by the trades and La Nina. All right, but it's not the actual temperatures that matter so much. It's the differences from normal, anomalies, differences from normal for this time of year. This clearly paints the picture. Warm water, not that warm, a degree above normal at depth down in the ocean, but making it to about 160 west and not 1 inch past there. Cold water, 4, 5, almost 6 degrees centigrade below normal. That's like 9 or 10 degrees below normal, filling the entire East Pacific. Where's the dateline? Right there, 180 west. So really, from the dateline the whole way to Ecuador, colder than normal water, driven, of course, by easterly trades that are stronger than normal, causing upwelling and just shutting the Kelvin wave cycle down, cutting the storm production machine down. Here's another model using the same data, basically painting the same picture. A finger of warmer, much warmer temperatures here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Pockets of 3 degrees centigrade, 2 to 3 degrees centigrade above normal at depth, but no Kelvin waves. This is not moving anywhere near to the east because there are no westerly anomalies here to push anything. So nothing to fuel El Nino, nothing to fuel storm development. And then if anything, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 5 degree below normal temperatures. Quite cold indeed, filling the entire East Pacific. So just two models telling us the exact same thing. And then if you don't like the models, well then here's a more direct measurement. This is ocean height. Okay, is the ocean higher than normal or lower than normal? Not in terms of waves or tides or anything. This is from the from one of the satellites. Strip out all the wave data. The Jason 3 satellite, there we go. Strip out all the wave data, strip out the tides, strip out the wind waves, and just where the ocean normally is as compared to normal. Is it still where it should be? No. 10, 15, 20 centimeters below normal. What's that mean? That means, and we're on, let's see, so there's the equator, there's the date line. You can see Mexico, Baja right there. So, Hawaii's right there. So basically south of Hawaii, massive indentation in the ocean surface. All that means is there's cold water at depth. Cold water contracts. It creates a little divot on the ocean surface. And so this is another way to try to confirm what the models were saying. You can literally see it's literally like, because the trades are nuking, they're pushing cold water this way, parting the warm water in the West Pacific. So the whole direction of everything is going in here. Philippines, where are they? Like up here, and there's your warm water pool there. That's what was feeding that typhoon the other day. And here's the trend chart, if you will. This is the West Pacific here. This is the East Pacific here. This is back in time, November, December a year ago. Warm water traversing from west to east. That's a Kelvin wave, right? Driven by westerly anomalies, driven by the active phase of the MJO moving over the Kelvin wave generation area. But then you can see April of this year, that all just shut down, and instead we started getting upwelling. Easterly winds started nuking over the East Pacific and over the whole equatorial Pacific, creating upwelling. We had a little bit of break in July. Then another bout of easterly anomalies. And look at this, much more pronounced just in the past, we'll say 3 to 5 days, this updates. This just showed up, was that 1, 2, 3, 4, 5, 6? 1, 2, 3, 4, 5. 2.5 degrees or more below normal. Now, just in one small area, but that gives you a sense of where we're heading towards in the next 2 to 3 months, because La Nina typically peaks like between Thanksgiving and mid-December, something like that. So keep that in mind as we move forward with the presentation. All right, sea surface temperature anomalies. Differences from normal for this time of year. Really, this chart hasn't changed a whole lot. We've been watching it for months. Cold water in control of all of South America to Ecuador and then along the equator, and really taking solid root on the equator from south of Baja the whole way out to, well, this is 160 west, but really out to the dateline. Quite cold in pockets here. That must mean the trades are blowing exceptionally hard in this area. What's driving those trades? High pressure in the Gulf of Alaska, high pressure off of South America. The two of them just create like a Venturi effect, a wind machine here. Constant upwelling and below normal temperatures, and once that gets, it's a global pattern. Once it starts blowing, creating the cold water on the ocean surface, the colder water then reinforces the high pressure systems. They continue to blow, if not blowing harder, and you get this, they call it a coupling of the ocean and the atmosphere, and that's where we're at. This is just a reinforcing, self-eating watermelon, I've heard it called. You know, it gets locked in, and you're not going to turn the machine off until it just gets to the point where it implodes on itself, but I think we're quite away from that happening. Temperature trend for the past 7 days. You see we've got warming here off of Ecuador, but that doesn't mean it's warm. It just means the temperatures there are a little bit warmer compared to what it was, but likewise, we have cooling the whole area from south of Baja out to, well, there's Hawaii, and you can even see blue out to the date line. So if anything, it's only getting colder, not warmer. Then the good backed off view. Again, this is sea surface temperature anomalies. Differences in temperature for this time of year. Clearly, all of South America is colder than normal. The whole way out to Well, where's the date line there? No, so we're even west of the date line. The whole equatorial Pacific, other than the area just north of the Galapagos, is colder than normal. And people go, well, yeah, it's really warm off of California and it's warm off of Australia, but for whatever reason, it is this area, 5 degrees north and south of the equator. The official El Nino monitoring region is from 5 degrees north, from 120 west to 170 west, right in there. And that is sort of the apex area between the South Pacific High and the North Pacific High. And when you see this signature, that clearly indicates temperatures are cooler than normal. The high pressure systems are stronger than normal. That means low pressure systems trying to move into the Pacific in winter months are just going to get deflected off to the north. The colder the water, the stronger the high. The harder it is to move the high, the stronger the storm has to be to try to penetrate that dome of high pressure. And this is not indicative of, oh yeah, we're going to have a completely normal winter. Probably not. And there's some indications, oh yeah, during analog La Nina years, you tend to get, more normal precipitation in California. Well, the issue with that is when you have a La Nina right after a strong El Nino, you actually do get enhanced precipitation in California driven by the real colder upper air temperatures. You can get dumps of snow like you wouldn't believe, but we're not coming off of a El Nino. We're like smack dab in the middle of nowhere's land, and this La Nina is just building and building. All this suggests to me is that there will be considerably below normal precipitation for California for this winter, including rainfall and snowfall. Sea surface temperature index in the Nino 1.2 region, that's the area right there along the Galapagos, Ecuador, and Peru. Temperatures are actually sort of trying to creep up a little bit. Minus 1.222 degrees today. Okay, but they've been hovering in the, I'll say, minus 1.5 degree range for quite a while now, and that's not going to change. But it's the official El Nino monitoring region, the Nino 3.4 region. We were talking about the area south of California out to about the dateline. The trend, down, down, down. Minus 1.681 degrees today. Okay. La Nina officially starts when you're half a degree below normal for 5 consecutive months. So we're from August to September, so October, we're only about 2 months into this thing, a little bit more, maybe almost 3 months now. So we're not officially in La Nina, by the strictest definition of the word, though clearly we are by you just look at all the data, and we're in La Nina, and we're only going deeper into that hole. The final El Nino La Nina indicator is the difference in pressure between Darwin and Australia and Tahiti, called the Southern Oscillation Index. When pressure is lower in Tahiti, the daily index, the entire index goes negative. If it stays negative for a long period of time, that can be a sign of the active phase of the MJO. If it stays negative for, a very long period of time, that can be a sign of El Nino. Unfortunately, the reverse is also true. Today we are positive, plus 28.76, very positive. And you sort of look down here, you can see, there's pockets of negatives. This looks like the beginning of the active phase of the MJO, about mid-October. And it looks like, maybe it's probably about over by now. The 30-day average takes some of the noise out of there. Value is plus 4.19, so that's not horrible. I mean, we were actually up to, plus 12.5, 12.58 back in October. The active phase of the MJO cut some of that out, but we expect this to start rising again. The 90-day average, when this gets in the 12 range, 12 to 13, then you're in La Nina. We're at 8.16 today. But we were, where were we? 8.84 there back in mid-October. Again, the active phase of the MJO cut some out, but we expect this to build back. Here's a 30-day moving SOI on a graph going back to January 2018. We were kind of in a La Nina then. And then in 2019, we kind of almost thought we were moving into El Nino, but we didn't. It was just neutral biased El Nino-ish. But you can see since October of 2019, a steady rise. Each one of these downward spikes here is the active phase of the MJO. You see that we're in a pretty good active phase of the MJO right now, but we know that that's all but about done, and these numbers will start skyrocketing up again. We expect it to probably go higher than whatever happened here in 2018, just given the water temperatures and the winds and the trades and everything that's going on. So this is our little bit of a break from the La Nina drudgery we expect. And then finally, the official El Nino sea surface temperature forecast, sea surface temperature anomaly forecast from the Cfs version 2 model. And you can see this is sea surface temperatures in the official El Nino monitoring region. They were warm back in January, April of 2020. And then after April, we started on this downward trend. Today, this is November 1st, roughly. This is mid-October right here. Steady downward. If you think we're cold now at minus we'll say 1.2 degrees, we're going down to supposedly minus 2.4 degrees at the peak. This is down on the equator. This is not locally, right? No bearing on local temperatures, but this gives you an indication of how strong La Nina would be, how strong the high pressure dome over the Pacific will be as we get into the depths of winter, and then the influence on local weather, that being that rainfall, and also the potential for storm production, probably does not bode particularly well. These images are kind of small, but you can look at here, November 2020. You get the sense this is pretty much what we're seeing today. Building as we get into December, January. We'll see if we can pop this guy up. There we go. All right, and you can see clearly, if you think the cold anomalies that we're seeing right now are strong, much worse as we get into January. Full bloom La Nina taking over, cold water, driven again by high pressure. Oh, that is California there, Mexico right there, Central America, you get the idea. High pressure up here, driving easterly winds. High pressure in the Southern Ocean, driving easterly winds. Massive upwelling between the two of them, pushing all warm water off to the west. Classic La Nina sort of signal. When you get this cold water syndrome and you have high pressure here, it just drives low pressure pushing off of Japan up to the north into the Bering Sea and then down along the coast, but a lot of it inland, not over the ocean, not great for storm production. That said, all the doom and gloom we've been talking about, I mean, there are some small gales that have formed. There is swell in the water pushing towards Hawaii and California. A second one is behind that. There's going to be a fair amount of wind, but we've talked about this. We know that that is going to be the problem this entire winter because high pressure is in control of the Pacific Ocean. So there will be a steady diet of north winds. Typically what happens as you get into the spring, that high pressure really gets revved up, and then the warm water that we've had starts really getting dug out. We know that there is a north wind event coming for Friday, Saturday. That should drop temperatures considerably along the California coast. It's probably only downward from there. That said, there's still potential for surf. And certainly Windswell. You just got to pick your times. We're coming out of the active phase of the MJO, so the next month or so might not be so great, but then as we get into past Thanksgiving, something like that, maybe things will start waking up again. I mean, there will be surf this winter. It just won't be strong. A bit concerned about the snow thing. The good news is that when you get into a La Nina, it will push the jet stream instead of into California, into Oregon and Washington. So if you can do a little bit of traveling and get snow that way, you're into skiing, boarding, whatever, And flooding can be an issue too during La Niñas up in the Pacific Northwest, because it's just like a fire hose takes aim at that area. So all things to consider depending upon where you live, what your sports aspirations are, and how much you can travel, and what the COVID situation does to ski resorts and whatnot. So plan accordingly is the name of the game. All right, so that's our video for this week. If you enjoyed it, give us a thumbs up. We'd really appreciate it. Subscribe if you like. You'll get notifications when we post videos. If not, go to stormsurf.com. We have a banner at the top of every page after we post the video. It will be there so you can get to it. All the data you've seen on tonight's presentation and much, much more is available at the site there too. You can pick through, peruse, follow it daily, hourly. Pretty much we're looking at every run of the models during the day, and then at the end of the week we do this video recap so you can test your skills and build your skills. All right, thanks for watching. We'll do this again next week, same time, same channel.